السلام عليكم. أنا أحمد حمدي محمد، طالب دراسات عليا طب بيطري جامعة القاهرة، دبلومة الرقابة على الأغذية. In this presentation we will talk about gel electrophoresis. We will cover these topics: introduction, principal types of gel electrophoresis, protocol of gel electrophoresis, and application. Gel electrophoresis is a lab technique used to separate and analyze DNA, RNA, or protein based on their size and charge. Principle of gel electrophoresis is movement of charged molecule through a gel matrix when the electric field is applied. DNA molecules have a negative charged phosphates along the DNA backbone, so occur migration towards the anode when electric field is applied. Smaller molecules move faster than larger molecules. The gel matrix is placed in a buffer solution, which provides ions to carry the electric current and maintain a constant pH. The samples to be analyzed are loaded into the gel matrix and subjected to an electric field. The electric field causes the molecule to move through the gel matrix towards an opposite charge. DNA, RNA, or protein can then be visualized by staining the gel. We have two types of gel electrophoresis. First type, agarose gel electrophoresis, which is the most commonly used type of gel electrophoresis for separating DNA fragments. The gel matrix made of agarose and the DNA fragments are loaded into the gel matrix using a counter. Once the DNA fragments have moved through the gel matrix, they can be visualized using a DNA stain such as ethidium bromide. The second type is the polyacrylamide gel electrophoresis, which is used for separating RNA and protein. The gel matrix is made of polyacrylamide, which provides higher resolution than agarose gel electrophoresis. The protocol of gel electrophoresis. We have 4 steps. Firstly, prepare the agarose or polyacrylamide gel. Secondly, loading of the sample. Thirdly, running the gel at the optimum voltage and the optimum time for effective separation. And the last step is staining the gel for viewing DNA. In this picture, we will show the instrument can be used in the gel electrophoresis: power supply, gel tank, casting tray, gel clamps, tank cover, and electrical lids. At the first, we prepare the casting tray. Seal the edges of the casting tray and put in the clamps. Place the casting tray on a level surface. None of the gel clamps should touch the surface of the casting tray. Secondly, we make an agarose gel. An agarose gel is prepared by combining agarose powder and a buffer solution. Use a flask that is several larger than the volume of a buffer. Swirl gently to give a uniform suspension and avoid lumps formation. Then we melt the agarose. The easiest way to boil the mixture is with a microwave oven. Gently stir a solution periodically when heating to allow all the grains agarose to dissolve. Then we cool agarose gel by placing the flask in a water bath set at 55 degrees Celsius. Then add gel-rich DNA dye and mix by a swirler. Then carefully pour the melted agarose solution in the casting tray and avoid air bubbles. Each of gel clamps should be submerged in the melted agarose solution and remove air bubbles with a pen or pipette type. When agarose cooled, forming a flexible gel, it should appear lighter in color when completely cooled. Carefully remove the cones and the tabs. The gel can be used immediately or stored in a fridge for a few days before use. If we will store it wrapped in cling film. Add enough electrophoresis buffer to cover the gel in a depth of at least 2 millimeters. Make sure each well is filled with buffer. The third step is loading the gel. Carefully place the pipette tip over a well and gently expel the sample. The sample should sink into the well. Be careful not to puncture the gel with the pipette tip. Then we will connect the electric field and occur movement of charged molecule to an opposite charge. The last step is the staining of the DNA. We have two types of stain: ethidium bromide and gelaret. Ethidium bromide has been the most commonly used DNA stain for many years, but has many limitations. Ethidium bromide is a powerful mutagen and moderately toxic. Gloves should be worn at all times. Only purchase a solution of ethidium bromide, not powder. Dispose of waste correctly because it is a hazard. Gelaret. The second type of stain is gelaret, a safer alternative to ethidium bromide. It is a new generation of safe nucleic acid gel stains, can't penetrate latex, gloves, and cell membranes, non-cytotoxic and non-mutagenic, not classified as hazardous waste. Gelaret require a UV light or blue light source to visualize the DNA. In this picture, we see the pattern of DNA bands under UV light. The last topic we cover is the application of gel electrophoresis. Gel electrophoresis can be used in the separation of DNA fragments for DNA fingerprinting to investigate crime scenes, and to analyze the results of polymerase chain reaction (PCI), to analyze genes associated with a particular illness, in DNA profiling for taxonomy studies, to distinguish different species, in particular testing using DNA fingerprinting, in the study of the structure and function of proteins, in the analysis of antibiotic resistance, in plotting technique for analysis of macromolecules, in the study of evolutionary relationship by analyzing genetic similarity among population or species. كده وصلنا آخر محاضرتنا. شكرا جدا لاستماعكم.